Hi, this is my ISP, which is a bike speedometer. So here's a quick demonstration. On the other side, it's compared to a GPS from my phone, which is just a screen recording. And it's during the same interval. So without further ado, here is a demonstration down a large hill. So we've reached a max speed of about 41 kilometers an hour, and let's compare that to the GPS. In fact, I would say that this is slightly more accurate just because the GPS approximates. But anyways, that is a quick demonstration. Now let's get into how this thing actually works. The bike computer, which can also measure distance if this switch is flipped to the right, gets all its information from a single read switch input, which is mounted on the fork of a bike. So a read switch is essentially a magnetic field sensing switch, so for demonstrative purposes it can be replaced with this standard push button. If a magnet is placed on the wheel of the bike, the read switch sends out a high pulse every time the magnet passes the fork. So in this demonstration, when this button is pressed, that means the wheel has completed the full revolution. By measuring the time between pulses, the computer can calculate speed using the circumference of the wheel, and by measuring the total number of pulses, it can calculate the distance traveled. The first thing about the bike computer to understand is the additional functions within its code. The first of which is light display. This function has two parameters: digit, which digit on the speedometer to light up, and number, which number to display. For example, light display 49 would light up the leftmost digit with a 9. It does this by storing the pin numbers of the CD4511 decoders in an array, then setting the correct pins high using the bit read function. The second function, readout, has a single parameter, disp, which is a 4-digit number that gets displayed on the bike computer. It works by splitting the 4-digit number into its 4 single digits, then feeding each digit through the light display function. In order to calculate the speed of the bike, the program waits for the moment the magnet passes the read switch, then starts a timer. It stops the timer when the wheel comes back around, then calculates the speed using this formula. Speed equals 3.6 times circumference over delta t. Then, if a second has gone by since the last revolution, it reads out the value of kph using the readout function. It multiplies the value of kph by 10 to account for the decimal point on the speedometer. In order to calculate the trip distance, the program uses one singular variable. Each time the wheel goes around, the variable revs is incremented by 1. Then, to read it out, it multiplies the total revolutions by the kilometers conversion and the wheel circumference. Finally, if it has been more than 2 seconds and the wheel hasn't come around again, the program sets the speed to 0 as the bike has stopped, and immediately reads out a 0. Thank you for watching this video. That's how my bike speedometer works.